Hello and welcome there to another episode of the Cliff Notes podcast, where we ask a leader and find their way. Today's guest is Chief Technology Officer and Director of the Software Design Solutions. He has been creating embedded software solutions for nearly 30 years. And today we're going to talk about embedded system software development and delivery and the process of improving it in IoT projects. Welcome today, Ed.
Thank you for having me on, Tristan.
I wanted to tackle your surname, but I need some more training. So maybe you could help me on your surname.
It's just like it's spelled. It's Kuzemchak.
No, that's not too bad. I'll have to Kuzemchak.
Correct.
We'll have to I'll have another run at that at the end. Been working with a good few Polish people this month, and they have their names when they introduce you. They're very normal sounding to me in a sort of Western way, but the spelling of them is very different. So
it gets to be a challenge.
Get used to. Yeah. What's the background of your sort of heritage, or where's your family name come from?
Very similar. It's Slovak.
Slovak. Okay, so that similar direction sort of thing.
But correct.
But presumably you've been not this side of the world. You live on the other side, as it were, for a good number of years. You always lived there?
That's correct. So we're here in the States. We're in Pittsburgh, Pennsylvania.
Mm-hmm. Oh, that's great. So I introduced you that you work with software development, especially with IoT projects. Maybe you could give us a bit more of an introduction to that.
Sure. I mean, my entire career has been in embedded software in one way or another. I spent a number of years building embedded software tools, compilers and debuggers and embedded operating systems. First for a defense contractor here in the States, and then for a small startup that built embedded software tools that was then purchased by Texas Instruments, and we had a good long run with that type of technology. And in doing that, I came to understand what embedded software engineers care about, what they care about deeply. They care about code size and power constraints and being able to fit as much as possible into the smallest, cheapest little parts. And so as I founded this company 17 years ago, we kind of kept that same idea and just started building embedded software systems for customers, both in terms of building things from the ground up, but also joining teams that were in progress, and just sometimes just as a set of very skilled hands that could join a project and spin up, or when someone wanted to go off in a new direction. Maybe they weren't really an embedded software company, but they wanted to add intelligence to a system that didn't have intelligence at the time.
Just to get a little bit more understanding, when you say embedded systems and the software there, is this software that's burnt into the code, burnt into the silicon, or is this embedded in some other way?
I'll call it firmware, because it's not burnt into the silicon in the way of a custom piece of silicon, but rather it's a microcontroller. Maybe it's say your anti-lock brakes in your car that may not be burnt into the silicon, but it's a general purpose microcontroller running some embedded code. And so things are kind of the lines are getting kind of gray, because when I first started this company, as I said, 17 years ago, people asked what I did. And I said, well, I work on software, but it's anything except what runs on a PC and talks to a database and puts up a web page. But now we have embedded systems that run on basically a Linux, hardened PC, and maybe they have a database, and maybe they have a web page with a touchscreen. And so those lines really do blur. But we're building those size of systems all the way down to very, very small systems that are, on a wearable, with no user interface, and they maybe only have to run in a few thousand lines of code instead of 100,000 lines of code.
Right. And does that mean you work with very different sort of parameters for performance, much more to do with sort of power consumption, size, other variables that someone who working on inverted commas more traditional software might not need to worry about so much?
There are, and it really depends on the domain. And so in a system like a wearable or a sensor on a piece of remote machinery, something that comes into play very often is power. How long can this system run on a coin cell or on a small, AA size battery or two? Because it's not so much that these batteries, they're not very expensive, but to actually send a technician out into the field to change a battery on, say, a meter on a pipeline or a monitor out in an agricultural field, I mean, that's a very expensive operation, and it has nothing to do with the cost of the battery. That's inexpensive compared to actually having that person drive out there.
Right. And is that the sort of projects that you often work on, is sort of a remote project or projects that are so distributed that there are many sites to their use?
Yeah, many of our projects are in what you would consider in IoT speak out at the edge. Building sensors and building that first level of gateway that the sensors report up to. We do combine those into an entire project sometimes with the cloud component and asset tracking and asset management. It really depends on on what the customer has in place already and what they need to where they need to go. One very important thing is, as people are entering into the IoT space, sometimes they just need to get a prototype together to understand, which part of the space should they be attacking, which part of their processes could they improve with IoT. And we really like to help people in those early phases understand, without launching a grand IoT project and designing hardware from ground up. We like to bring in off the shelf type hardware, our asset management system, and kind of put together a quick prototype to say, okay, you have these machinery in your plants. Instead of replacing the machinery, because no one wants to do that, maybe you just apply some add-on sensors to those machines, and let's collect some data and let's analyze it. Let's get some data scientists involved, and let's get some analytics in there to understand what is worth collecting and what's not worth collecting. And in those kind of projects, much of our time is spent on the sensors out at the edge, and doing the data collection itself.
That's great. That leads me into my next question of so where would a journey start with this, and what is this edge that you are describing, just to help other people understand?
Sure. Yeah. I mean, so when you think about the IoT, eventually you are sensing something physical. And so, when you think about, an IoT system that is measuring, say, moisture out in a field in agricultural deployment, let's say, that edge is that final sensor that is stuck in the ground, and it is measuring the moisture in the field, or how much rain was received by that area this past week. And so that is kind of the edge of the system. And then, from there, that data is then sent to often a middle kind of layer that collects the, whatever sensors are nearby, and then finally up to the cloud into an asset management type system that is what you're used to seeing, and with the fancy dashboards and everything else. And so, getting started really involves understanding what's worth collecting. What is there, what is there that is unique about this customer's process that could be improved by better analytics, by better, quicker measurements. Each of our customers has already some process in place, and they're doing many things manually, and maybe some of them they're doing in an automated way, and we're just trying to help them understand, you know, what's the low hanging fruit that could get them some initial payback.
And the payback would be is these efficiencies or understanding, or I mean, what sort of things are we looking for?
It is often efficiencies, and efficiencies can come in the way of efficiencies of personnel. In other words, if you had, picture again the person who goes around and services all of these sensors, and maybe today, if they have no way of knowing, perhaps today the person may be running around and collecting the data from these sensors. And we live here in the U.S. where not that many years ago, all of the oil wells, gas wells, natural gas wells, those kinds of things had literally round paper charts that charted how much that well produced. And every week, someone would run around and they'd take that paper chart off and they'd stick a new one on, and they'd line the pen back up, and away it would go. And so now you have an entire person's job just doing that, when that data could be just sent up automatically, and that person can do something else more useful. So there's those efficiencies, but there's also the efficiencies of time, where if you don't have a delay, you can start to understand data in a more real-time way. And so you can start to understand that this piece of equipment is behaving in a way that is abnormal. And so now it's an efficiency of time, but it's also a reliability and safety issue then as well.
Mm-hmm. So if we're seeing machinery vibrating too much or overheating or different pieces, uh, is this the sort of stuff that you're able to sort of monitor and pull together in a form that could make remedial action sort of faster and cheaper to maintain?
Yeah, these are exactly the kind of things when people talk about predictive maintenance. When they talk, when it's a form of preventative maintenance where you can start to predict, this machine is starting to act in an abnormal way. It does need to get some service, and if you have enough data, you can start to apply heuristics or machine learning and determine how long I don't know how long this machine could go before it receives some type of maintenance to keep it going correctly. And so I think that those kinds of things are part of the payback of IoT. And it's not the same for everyone. Everyone's business has some things in common, some things that can be reused, some ideas, but each business has a kind of a different weighting on those priorities, and that needs to be taken into account.
Sponsorship of this podcast has been brought to you by Holding Bay, the digital web agency. Holding Bay specialises in working with B2B companies like manufacturers to build better solutions and drive better sales funnels. So if you would like to build a web application or improve your branding and sales funnel, get in contact today. holdingbay.co.uk or call us on 01273 044 019. And if we're talking, say people work with have manufacturing facilities, reading the words IoT and millions of sensors and masses of devices and things always brings up the picture of some sort of matrix time complexity and vast millions to install and get up and running. Is it the sort of thing that can be worked on in much sort of smaller and simpler forms without having to instrument every particular device in the building?
I think that's one of the challenges that we're trying to overcome is to speak with customers early to understand, you want to have your grand vision of where you want to be eventually, but you really want to build that incrementally. We've been building software in an agile way now for the almost the entire 17 years that we've been a software company. And I think that this adoption of IoT needs to also be done in an agile way. And what I mean by that is you start with something small. You start with something that is almost a no-brainer, and you put that together quickly, and you do the data collection and the analysis and understand the paybacks. And then you build on that. And you expect to have not one giant rollout, in 3 years, but a rollout every 3 to 6 months with more capability and more understanding. And that way, what you've done is you've given, the opportunity for fast feedback and quick wins for your seed levels, but it's also, the classic agile mantra of fail fast. If you're going down the wrong direction, you in 3 months, not in 3 years, and you can adjust. And often much sooner than 3 months. You start a data collection project with off-the-shelf sensors, and you find out that, well, this data just isn't very useful, you know. And how do you know that? You involve the domain experts at the company, because they already know, what you have a lot of people with this inherent knowledge of their product and this inherent knowledge of their processes. And those people can help tremendously, help understand what is worth collecting and what's not.
And I mean, what might a typical example be? Or maybe you could talk about a sort of more particular case to get us to see a sort of more of a picture of it.
Sure, sure. I'll talk about a customer that is in the manufacturing space in transportation, and they build systems that are used in transportation. I won't go into too terrible much detail, but these are finely machined pieces of equipment that are used in the transportation industry, and this customer has, you know folks on staff that have been working with these things, testing these things, building these things for decades, and they know them inside and out, and they could say, look, if when one of these comes back for repair or refurb, we know a set of things that we need to look at. Well, what if we could look at those things live as the system is being operated by the customer, and not every 6 months or 2 years when they come back for refurb? We could begin to collect a lot more knowledge about exactly when do they start to go out of spec, exactly how are they being used, and this way you could actually build a better product, because you could start to understand, here's where we ought to have our maintenance intervals. Maybe they're too short right now, maybe they're too long right now. And you could start to really gain some of that knowledge if you could collect the data in real time.
And with the data collection, do you then feed that into other systems or reports, or you help be able to interpret this and present it as well?
Yeah, so I've talked about that recently. Our mantra for data collection is to use the data collection techniques that you're most comfortable with as a customer. And so if the customer this customer had just sheets and sheets of Microsoft Excel, and we're very comfortable with them just using that in the beginning. We don't have to go get a fancy analytics package if they're comfortable with Excel. And so what we tend to do is, our asset management cloud-based system captures the data. It could display it in a number of different ways, but it can also export it to Excel for this customer. There are other customers that just want to see a simple graph or something like that. But then there are customers, because of the industry that they're in, they have a more mature process model that is built around one of these analytic systems like Pi or something like that that is much more sophisticated, and you need to be able to integrate any data that you bring up with that kind of system because that's what they're used to.
And then I guess this is wraps into the integration, and also when you were talking about, say, sensors that are out by an oil well or in a field monitoring, is all the data or the data when it's collected secure enough? Because it's not really going to be possible to keep this thing secure if it's just out in the elements. Is it? I mean, is this stuff safe to work with?
That's something that has to be brought into the system from the start. And so we have on staff certified security engineers, and we have done independent consulting in the medical industry and in the defense industry for embedded system security. And so an embedded system, as you just mentioned, is unique because it contains data that if you just walked up and ripped it off the side of the oil well, you would have the system and it would have the data inside of it. And so, there's a concept in embedded system security that says that data should be secure at rest and secure in transit. And what that means is, as these measurements are made, if they are measurements which are which are required to be secure. And that's a per customer, per domain, per industry type of thing. It varies wildly. Like for example, if you were a soft drink manufacturer, let's say, and you had a bunch of IoT systems in your plant, you certainly want the settings of all your valves and meters and all those things to be secure at rest and secure in transit, because you don't want someone to be able to sit in the parking lot with a Wi-Fi sniffer or a Bluetooth sniffer or whatever and basically collect the recipe for your soft drink out of just by knowing what valves are turned to what settings. And in fact, you don't want the hedge fund folks to sit there and collect how many bottles were even made that month. And so there's a lot of those types of things that, if you're a agricultural firm, you might not care if someone can connect your sensor and figure out how much it rained that day, because they could also just go to the weather service and get that same information. So it's not much value.
Yeah, no, that sounds that you've got that covered. So appreciate that. And is that one of the biggest challenges to adoption, or are there other challenges for businesses to adopt systems like this?
I think there's several challenges. Certainly understanding the both the security and privacy of the data, and those are kind of two different things. That's certainly a challenge, as well as I would call it the IT versus OT disconnect sometimes. And this is something that I say that, when we have an early kind of brainstorming meeting where we're going to talk about, what's possible, what's capable, what should be done first, we want to make sure that IT is in that room at that time, because it's a real it's a real disconnect if you wait until you're 3/4 of the way through the project or 95% of the way through the project and you show up with sensors and you just bring the IT person in at that time and say, we want to put these on the network. You can imagine how that discussion goes if that's the first time they've heard of it.
I think that's an interesting one. As I always imagine, the first thing is to make sure that the C-suite and the senior management are bought in so that they can help buy the staff in. But I think that's equally a good point, that you don't want to feel like you're bringing in a new system that is not going to be supported or is going to be rejected by any party, and IT being a key one.
Yeah, I think there's a set of four or five different roles that need to be in that first brainstorming meeting. Certainly the C levels, because they are the project sponsors. There's IT for the reason I just mentioned. There's these domain experts, and the domain experts. We don't think of these folks as folks from R&D. These are more likely your plant manager or your shift foreman in an industrial setting, because or maybe it's your head quality person if what you're trying to improve is quality. And those people understand deeply the processes you're trying to improve, and those are the folks where you're going to get all of the useful low hanging fruit. And of course, someone that knows a good deal about what's possible in the IoT world, what's easy, what's hard, and that's really the seat that we often fill in these brainstorming meetings.
Indeed, indeed. I do believe that this can end up being an extra tool for the people working on the facility and working on the lines rather than just a management metric. So yeah, it's definitely worth having it be useful and be a part of what the domain experts need. And I mean, where's next for these sort of technologies, or what's the sort of next steps you're seeing with companies that have sort of started adopting it and then are looking to go further?
I think that one of the big things, and this is kind of related to our current situation with COVID, is folks are wanting to do more remote monitoring and more remote collaboration of data. And so it's important now for companies, as manufacturing starts to open back up, that we need to spread people out further in manufacturing organizations. So we need to have one person be able to have a sense of more than the machine they're currently standing in front of. So anything that can help that is certainly a win. But then also, there's a large number of people in these organizations that used to be able to walk down to the floor of the manufacturing organization and do quality checks, do those kinds of things, look at reports. Maybe they were a piece of paper back then. And being able to access data and collaborate about data remotely, over a screen share, is terribly important, especially now. And it was useful before, but I think it's critical now.
Indeed, indeed. Yeah, I was having a conversation on one of these other interviews, and they were very happy that before the COVID-19 lockdown reduced their plant operation, they'd already implemented some ability to do remote checks and remote form filling. The filling was form filling was digital. Otherwise, the person's job to go around and collect all those papers each day and monitor that stuff wasn't going to be practical anymore because of the distancing and the reduced staff on the floor. Being able to have that away just in a much smaller scale was an advantage. So the same with the monitoring and assessment. That's cool. So I mean, we've sort of got into it that we're living in sort of these changing times and this sort of adaptation, and a lot of companies have been looking more slowly more at sort of cobots and other monitoring devices and automation in their plants. Have you seen some part that you feel the work that your company is doing is helping shape this future, or something you're looking forward towards?
I think so. I mean, one of the things that we have embraced in the last year that is really starting to change the way data is collected are these low power, low bandwidth cellular technologies, and I'm talking about what in the States here is called LTE Cat M1, and also narrowband IoT, NB-IoT. And that's, I mean, and this, these two technologies really mean that that a device that is capable of running on a battery can now make cellular connection to a cellular network. And that was possible before, but the hardware was reasonably expensive. The data plans were reasonably expensive. And so you couldn't put cellular connectivity on a remote device and unless, the thing you were attaching that to was worth, quite a bit of money to monitor. Now we have the opportunity with a data plan that is on the order of a few dollars a month, two, three, and we can connect and send data all the way to the cloud in one shot. So that we have the opportunity, as I mentioned, to say this monitor out in an agricultural field or out on a pipeline or something like that. We don't have to have something nearby connected to the internet because you have the opportunity now, as long as you have cellular, and it's reasonably pervasive now, we have the opportunity to get this data up there. That's going to change the use cases that are possible that weren't possible before. We've been doing a number of prototypes with that technology for customers.
I think that's an interesting technology. I've not looked into some of these newer ones, but we have been looking in as this sort of local hobby group that have been working on. They've been putting up, I think we're up to about 3 masts now for some LoRa around the city area in Brighton. We're in as a community project, and then letting people experiment with what data that they can capture. But that's another much sort of lower bandwidth and more different characteristic device. So it's interesting the way of making things efficient and experimenting with this stuff.
I think LoRa is very compelling. It's tough here in the States because we're so broad, and it's hard to cover a lot of space. But in the right use case, in a metropolitan area, for example, if you're doing tracking in a metropolitan area and you don't have to track clean out in the middle of Kansas somewhere, then nothing against Kansas, but I think that if you're able to build the infrastructure, I think LoRa is a very compelling use case.
Mm-hmm. Yeah, I mean, this is the idea is public access data and public information data. The city was also interested to see, what could we collect and share back as sort of common data sets, and just people making their own sort of small monitoring devices. Great. And then periodically this data gets collected. So it's an interesting space. There's so much sort of being tried out as a practice and a process, as well as the more sophisticated end. No, so it's been great talking with you, and always like to end on a little bit of sort of a more fun question. If you were able to make one of your potential clients or actual clients a superhero for the moment, and they were boxed into the corner and they need to come out on top, what 2 things would they likely grab to get out of the corner, if you could put yourself in their shoes?
Sure. So I guess the 2 things. I'm in a techie frame of mind today because of what I've been working on. But the 2 things that I would certainly want them to grab would be, one, a Cat M1 radio, and the other is Python. Because we have a terrific little off-the-shelf board that we've been using for doing data collection and sending up to our cloud instance. And if we can very quickly get something together and hand it to someone and say, look, with this you can get your temperatures read and all of these things sent up there. And so I think that those are 2 things that everyone should get some familiarity with. Python, because it's so quick to prototype things with, and Cat M1 because there's nothing like having instant access up to the cloud without having to say, oh, but I need to be near a Wi-Fi, or I need to be connect to my phone with Bluetooth or whatever.
That's great. I know one of those. I don't know the other, so I shall have to do some more research
Excellent.
and get my superhero cape on. So that's great for spending some time with us today, Ed. And maybe you could give us a bit of information about your company or how to get hold of you if there's some businesses that are looking to explore this opportunity.
Sure, we'd love to talk to folks. So they can get a hold of us by coming to our website at softwaredesignsolutions.com. And there we post everything that we work on and great conversations like this. You can also find us on Twitter at Software Design 8, and you can connect. You can find me on LinkedIn.
Great, thank you. And you're looking for other embedded software projects to work with companies in this space. Is there any sort of geographical regions or anything else like that you work with?
We actually work with folks all over the world. I mean, we're located here in Pittsburgh, but we currently have clients and projects worldwide.
That's great. That's great. Thanks very much for your time then.
Thank you, Tristan, for having me.
Thanks for joining us again today on the Cliff Notes podcast. If you want to get in contact with myself or the guest, we'll post the details in the show notes, or visit cliffnotespodcast.com, or contact us on Twitter at cliffnotespod. Thanks again. We look forward to seeing you soon. And just as a little post comment, I couldn't let you go without talking to you a little bit about your amazing converted mobile home with a telescope on it. So could you give us a little bit of an idea? I'll see if I can share a photo afterwards as well.
Yeah, and so I did give you the website, right, where I posted the whole story, right? Yeah. Oh, it's been terrific. I was in it last night, and I got clouded out by about 3:00, but I was already in the bunk napping because I now have it automated enough that I can set up an imaging session. I use an open source astronomy, basically controlling software that this is the same set that professional observatories use, and it's all open source. It's amazing, and I can set up an imaging session to say, go to this object and lock in on it and focus and start imaging, and it'll image for like an hour and build up those images. I've learned so much about not just the optics side of it, but then after you actually collect the image, there's so much to actually producing the kinds of images that you see on that website, because they are all kinds of noise reduction and integration techniques, because I don't just take one 30-minute or 60-minute image. I take maybe 30 2-minute images and then use this software to stack them, literally almost stack them up to build up signal. And of course, as you build up signal, you build up noise as well, and you have to get that subtracted out. And there's a lot of almost art to the processing that's after the fact.
That's great. I feel like it's something that I'd like to get back into when I have a bit more space. Where I'm staying at the moment, we're a bit out of the city centre, and we get some quite clear skies.
Oh, nice.
Takes me back from I don't know how old I must have been. I'll have to look back at the calendar sometime, but it felt like about 8 or 10 or something. Halley's Comet was passing over the UK, and I can remember standing outside one of the large observatories in the UK in a big long procession queue in the middle of the night, just to have my sort of 2 seconds looking through the giant telescope to see it. And I think the process of waiting was probably almost as exciting as getting to the other end, because you only got a few seconds. But so just on the technical side, I know some people do like some sort of technical specifications too when they listen to the show. It's quite a big lens or a big piece that you work with, and My word, it looks big.
The scope is not terribly large. It's 7.5
Okay.
inches in diameter.
Okay, but it's motorized or whatever, so it's
It's
tracking
all
the.
computerized, and it
Mhm.
has to give you a crazy statistic. There are 5 cameras in use just to make that thing work. Um, there's the one that actually takes the image that I post, and that's a Peltier cooled CCD, or actually it's a Peltier cooled CMOS sensor, and so that's how it can image for that long. Because if you just had your cell phone, you could actually get your cell phone to image that long if you hacked the software, but the image would just be all washed out because the sensor would heat up. And so it's actually cooled to minus 15 C inside. So it's cooled to minus 15. And so that there's that camera. There's a whole nother camera that locks onto a star and makes the mount track that star precisely. And so it's not enough just to know, oh, we'll just make the mount move in the same amount the Earth moves. Well, there's gears involved, and gears, have some amount of imprecision to them. So we actually lock onto a star. There's a third camera just to align the mount with the North Star. And there's 2 more cameras just to keep track of everything going on in the observatory. One looking at the whole setup, and one looking right out the scope to make sure that I'm looking out the little slot in the dome correctly, and the dome has synced things. So with the help of 5 cameras, I can take one picture. It's very odd.
No, that's
And it all runs on a Raspberry Pi.
that's great. That's great. Raspberry Pis
Yeah,
keep popping up in all different locations. The
yeah,
power of something so small and
it's wild.
simple.
Yeah, it's crazy. There's just so much performance in one of those little things.
Well, that's great. I'm excited to keep seeing more of your images that come out,
Yeah,
and we'll
yeah.
just tag that on the end of the show.
Yep, keep visiting. I have a backlog now. I'd say we're ending the new moon cycle, and we'll be heading into the full moon cycle where I don't bother going out, so I can actually catch up on the processing. It takes me almost as long to post process an image as it does for me to take the image.
That's great. Well, thanks again for joining us.
Thank you for having me, Tristan. I look forward to it. So you'll send me over a link once you get this processed and posted. We'll socialize it on our side.
Thanks again. We look forward to seeing you soon.